Hello and welcome to this video lesson on chemical equations, which is part of the amount of substance series of lessons. So in this lesson, let's see what we'll want to be able to do by the end of it. We will want to be able to balance equations for unfamiliar reactions. So any reaction you might be given, you want to be able to balance it. You will have a reaction where the reactants and the products are specified. And you'll have to balance it. And as well as that, we want to be able to write balanced and full ionic equations. So not just balanced full equations, but also balanced ionic equations for the reactions that we'll study. Okay, so let's have a look at balancing equations first. And give ourselves a reminder of balancing equations. So let's start off with this reaction here. So let's have some sulfuric acid and let's react it with some sodium hydroxide, and of course that's going to make the salt sodium sulfate, and we're also going to get some water. Okay, so if that's what we're given and we're told to balance it, the first thing you want to do, and as you get practiced at it, you might not need to go through this in all the full detail, but for now let's do so. Okay, so what you want to do is you want to write down all of the reactants and products. So we've got some hydrogen, and we've got some sodium, and we've got some oxygen, and we've got some sulfur. So there are four atoms in the ionic compounds there. And to start with, we're going to count up on the left-hand side how many hydrogens we've got. And you see we've got 3 hydrogens. We've got 2 in the sulfuric acid and 1 in the sodium hydroxide, making 3. And in sodiums, we've got none in the sulfuric acid, but we have 1 in the sodium hydroxide, so we'll put a 1 there. Oxygens, we've got 4 in sulfuric acid and 1 in sodium hydroxide, so we can put 5 there. And sulfurs, we've just got 1. Okay, that's for the reactants. Let's do exactly the same for the products. So we've got sodium and hydrogen, oxygen and sulfur. And so on the right hand side, if we count up the hydrogens, we can see we've got 2 hydrogens in the water, and we've got 2 sodiums in the sodium sulfate, and we've got 5 oxygens, 4 in the sodium sulfate, 1 in the water, and sulfur we have 1. Okay, so the first thing that you'd notice is that we have 1 sodium here and 2 sodiums there. So what we could do is we could put a big 2 in here. So then we would have 2 sodium hydroxides. So what that would do is would mean that on the reactant side we would go from 1 sodium to 2, and this would now balance with how many sodium ions we've got on the right hand side. But making up 2 formula units of sodium hydroxide also changes the number of oxygens on the reactant side. So the 5 goes to 6 oxygens, and we're also adding another hydrogen, so the 3 goes to 4 hydrogens. And the next thing you might notice is that on the reactant side we've got 4 hydrogens, but on the product side we only have 2. So what we could do is you could, on the product side, you could change 1 water into 2 waters. Okay, so what that would do is it would mean that on the product side you would now have 4 hydrogens, but you're also changing the number of oxygens on the product side. So that changes the 5 oxygens to 6 oxygens. And so now what you can do is, let's just switch color again. You can go through a little check. So hydrogens, we've got 4 and 4. Sodiums, we've got 2 and 2. Oxygens, we've got 6 and 6. And sulfurs, we've got 1 and 1. So now we can say that this equation, as is written here with the 2 sodium hydroxides and the 2 waters, is now balanced. So let's do another example. Let's do this example. So we've got C2H6 plus oxygen gas. They react together and going to give us some carbon dioxide and some water. Simple combustion reaction. Let's balance that. Okay, as before, let's write down each of the elements. So we've got carbon, we've got hydrogen, and we've got oxygen. So we want to count the number of each of these in the reactants and also in the products. So we've got carbon, hydrogen, and oxygen in the 2 products as well. So reactants first, let's count them up. Carbons, we've got 2. Hydrogens, we've got 6. Oxygens, we've got 2. And as far as the products are concerned, in carbon dioxide we have just 1 carbon. Hydrogens, we've got 2. And oxygens, we have 3. Okay, so what is the first thing we should balance? I'd suggest the first thing to balance would be the carbons. It's not obligatory to do it this way, but you see on the reactant side we've got 2 carbons, on the product side we've got 1 carbon. So what you could do is you could write 2 carbon dioxides on the product side. So as well as changing this 1 carbon to 2 carbons, you would also have to change this 3 into 5. And next, let's have a look at hydrogen. We have 6 on the reactant side, 2 on the product side. So you could what you could do to make the hydrogens balance is you could put a 3 in front of the water molecule. So in which case you would be changing this 2 into a 6, which now balances, but also we've added an extra couple of oxygens, right? So you would have to change that 5 into a 7. So now let's have a look at the oxygens. We've got 2 on the left hand side, 7 on the right hand side, and so we have to put a number in here, right, to balance the oxygens. And if we put in 3.5, then 3.5 times 2 is 7, and that would balance. But can we write 3.5? Well, in this case we can, and the reason why we can is that we have a diatomic molecule of oxygen, and so we can write a 3.5 for the oxygen molecule, and therefore it's balanced. We're allowed to do that. However, you know, you can't do, let's say you had you put in half a water molecule, that wouldn't be allowed, because then you would be splitting an oxygen atom in 2, which wouldn't be allowed. So that's not allowed, but this 3.5 of O2 would be allowed. So now it balances. Should we just going to go through a check? Now we've got 2 and 2. We've got 6 and 6 hydrogens, and we've got 7 and 7 oxygens. So that balances nicely. Now I think we'll move on to ionic equations. Okay, here's ionic equations, and the thing about ionic equations is that they apply to reactions involving ions in solution. So that's the type of reaction that we use ionic equations for. And the thing about ionic equations is that we only include the species that change. And so that's reacting particles and the products that they form. They would change because they're reacting and forming products, but anything that doesn't change isn't included in the final ionic equation. Okay, so we generally follow 3 steps to create an ionic equation, and the first step is that we write a full balanced equation. So we start from the normal full balanced equation, and once we have that, then what we do is we split the dissolved ionic species. So you might dissolve sodium chloride up in water, and so you would split the sodium ions and the chloride ions, you'd split them up. And then what you would do is you would strike out any ions that appear on both sides. And by doing that, that's when you end up with only things that change. So you would satisfy that second condition of an ionic equation. Okay, so there's the general 3-step process. I think it's best if we run through a couple of examples to make that clear for you. So here's a question for you. It comes from the CGP book, as usual. So we're going to write an ionic equation for the reaction between sodium hydroxide and nitric acid. And we've been given an equation, but we don't know whether it's balanced yet. We should check that it's balanced, would be our first step. So let's look at hydrogens. We've got 1, 2 on the reaction side, reactants side, and we've got 2 on the products side. So hydrogen balances. Nitrogen, we've got 1 and 1. Oxygen, we've got 4 and 4. Sodium, we have 1 and 1. Okay, so it is balanced. So that's kind. They've given us the balanced full equation for us. So step 1 is now done. So step 2, you'll remember, is to write out all the ions. Okay, so let's do that. We've got in nitric acid, when you see we've got aqueous nitric acid, so that means it's dissolved, and so you would have a hydrogen ion, and you would have a nitrate ion, and then for the sodium hydroxide you have a sodium ion and you have a hydroxide ion, and they are what's in the solution. They react and you get sodium nitrate, which is also aqueous. Okay, and also aqueous, so we're going to have a sodium ion swimming around there, and we're going to have a nitrate ion also swimming around. And we're not going to split this because, as you know, a water molecule is a molecule, it's not ionic, and so we will leave that as H2O, liquid. Okay, so they're all our ions, and the next step, of course, would be to cross out everything that occurs on both sides. And if it occurs on both sides, it's not changed, and we don't want it in the ionic equation. So you can see that nitrates appear on both sides, so let's cross those out. We can also see that the sodium ions appear on both sides, so we could cross those out. But the hydrogen ions and the hydroxide ions, they react together to make the water molecule, and they're left, so we're not going to cross those out. So that leaves the ionic equation. All right, let's just write it out without all the crossings out. You've got a hydrogen ion. We can put the aqueous back in now. You can have the hydroxide ion, also aqueous, and they react together and they make a water molecule, which is liquid. Okay, so that is the full ionic equation. The last step, quite important, is just to make sure that it balances as well as charge is concerned. as well as the actual atoms. So atoms, two hydrogens, one oxygen. Very quickly you can see that balances as far as the atoms is concerned. But let's see if the charges are concerned. Well, we've got one positive here and one negative here. So the charge on the left-hand side is 0, and the charge on the right-hand side is also 0 because a water molecule is neutral. And so the charge is balanced as well. So that there, without the red scribblings on top of it, is a good ionic equation. Okay, let's try another example. So here's a slightly more complicated ionic equation to write. We've got some sodium phosphate and some calcium chloride, both in aqueous solution. So those ions are going to split up, and they are going to react and form sodium chloride, which stays in solution because it's soluble. However, the calcium phosphate that is produced, you notice from the solid state symbol here, precipitates out, and so we're not going to split that up into ions because they're not mobile if they're solid. So you'll remember that step one is to write a balanced equation. So why don't you pause the video, balance that equation, and come back and check that it's the same as my balanced equation. Okay, hopefully you've done that and balanced this equation, and what you should get is 2 moles of sodium phosphate and 3 moles of calcium chloride. They react together. They're going to give you 6 moles of sodium chloride. Alongside 1 mole of calcium phosphate. Solid. Okay, so there's our balanced equation. That's our first step of the process to get an ionic equation. And you'll remember the second step is to split all the mobile ions, that is those that are dissolved, split them up into separate ions. Okay, so you're going to see that we've got, in the sodium phosphate, we've got 6 sodium ions. So we're going to write down 6 Na, and you know they exist as 1 plus ions. And also from the sodium phosphate, we've got 2 phosphate ions. And if you can't remember the charge of a phosphate ion, then it's on the data sheet, but it's actually a 3 minus ion, which you could work out from the fact that you've got 6 1 plus ions in the sodiums. So we have 2 of those, PO4 3 minus ions, swimming around in solution. Of course, we've got 3 of the calcium, and you'll remember calcium anyway, is calcium 2 plus ions. And we've got 3 times 2, which is 6 chloride ions, and you remember that chloride is the 1 minus ion. Okay, and on the right hand side we have an aqueous solution of sodium chloride, so we have 6 sodium 1 plus ions, 6 chloride ions. And we're not going to split the calcium phosphate up, so that stays written as it is, because that's a solid. It stays like that. Okay, so that was our second step. And what of course we need to do now is cross out the ions that appear on both sides of the equation, i.e. those that don't take part in the reaction. And so let me switch to red. So you can see we've got 6 sodiums on the left and 6 sodiums on the right, so we'll cross the sodiums out. The 2 phosphates are in aqueous solution on the left, but they're combined with the calcium to make calcium phosphate on the right. So they do change. So we're not going to cross these 2 phosphate ions out. And that applies also to the calcium ions, because they're in solution on the left-hand side of the equation, the reaction side of the equation, the reactants side of the equation, and yet they're in a solid precipitate on the right-hand side, the products side. So we're going to leave the calciums there, and the 6 chlorides are on both sides, so we can cross the 6 chlorides out, and that's all the crossing out we need to do. And that leaves us with the ionic equation. So let's just write it out without the crossings out. So we've got the 2 phosphate 3 minus ions. We've got the 3 calcium 2 plus ions, and they're reacting to form calcium phosphate, Ca3 PO42. And let's put some state symbols in there. And that's our ionic equation. Last little check to do is to just check that the charges balance. Let's do the charges in green, shall we? So the charges here are 6 minus, because we've got 2 3 minus ions. And the charges here are 6 plus, because we've got 3 2 plus ions. So they're going to combine to make 0. And we've got a neutral compound here. So that is 0, 2. So the charge is balanced, and so we can assume that that is a correct ionic equation. Okay, I think that's that's about it for chemical equations. Let's just check we've covered off all of the lesson objectives, and they are here. All right, so we were to balance equations for unfamiliar reactions when reactants and products are specified. And I think we've done that. We had a couple of examples of balancing equations, and we've also written full balanced and full ionic equations for a couple of different reactions. So I think we've covered that one off too. So hopefully that's been clear for you, and I'll see you in the next video lesson. Thank you very much.